Hello everyone, welcome back to the host code. Today we are going to solve a LeetCode daily question step by step in Java. And today's question is maximum number of events that can be attended to. And this is a hard level question. And yesterday we have the same similar problem. If you haven't watched my solution for LeetCode maximum number of events that can be attended, I highly recommend checking it out first. We covered the brute force approach and the greedy solution in the detail over there, which will give you a perfect foundation for today's solution. Okay, so today's problem adds an exciting twist, like which we now have event values and can attend at most k events. This transforms our greedy approach into a dynamic programming challenge. So let's dive in, right? So let's discuss the problem statement first. The problem statement is you're given an array of events and events I start day, end day, and the value of the event. Okay, and the ith event starts at start day I and ends at end day I. And if you have attended this meeting, you will receive a value of value I. You're also given an integer k which represents the maximum number of events you can attend. Like they will be given an array of events and you will be given an integer, so this decides how many events you can attend, right? So yesterday's problem was pretty simple when we compare this with yesterday's problem. So yesterday we just have a start day and the end day without any value, so value is considered as one only. So the change is we get the value to attend a meeting. So this is a change which makes only DP solution works on this. Why doesn't a greedy program doesn't work on this? We'll discuss it in the notepad, right? We'll discuss it in the notepad. So if you have seen the constraints, the event length is less than equals to 1 and k, right? Okay, k into events dot length less than equal to 10 to the power 6. So it's okay. So based on these constraints, we need to follow code the approach. Like we need to discuss that approach and code it. So let's get into the notepad and discuss a little bit of the what are the types of approaches we can follow and why doesn't greedy approach that we have followed yesterday, which doesn't work to this problem right now. So yesterday we used greedy approach, right, where we attended the event that ended earliest. This worked because all the events had same value. One, we could attend unlimited events and we just wanted to maximize the count. These were the reasons we just followed the greedy approach with priority queue. And but now the events have different values. We get different values attending a different meeting, right? Sorry, different event. So and there are also limited events we can attend, and at an event ending later might have much higher value also, right? Yesterday we were just considering that attending an event which ends earliest would make a better approach because we need to attend the maximum events. But now we have the value for the event, so it doesn't matter how far the event ends, but we just need to make sure that event ending later might have much higher value. And see, we need to make a strategic choices about which event to skip, right? So this is a classic case where greedy fails and we need dynamic programming over here. So the optimal solution would be following a dynamic programming DP approach. Okay, so what are the key insights we can take from this? The key insights we can take from this is, for each event we have two choices, right? Whether we need to attend the meeting or skip this meeting, right? Attend the meeting or skip the meeting, right? So if you attend the meeting, solve optimally for remaining events that don't conflict. We just need to make sure that we solve for remaining events events that don't conflict. Okay. What if we want to skip the event? We need to optimally see what are the remaining events. Solve for remaining events. Yeah, this is the only thing we have, like, we need to do. So we need to choose the option that gives us maximum value also. We need to choose the option which gives us maximum value, option which gives us max value, right? We won't be attending an event with zero value, right? We might be seeing the value, we might be checking how much value we get from that event, and we just attend that event, right? So we just need to define a state. For example, if I say we just need to define a state, so just see dp I and j, just visualize it. So this takes a max value we can get from events. We can get from events from I to n minus 1, right? From I to n minus 1 using most j events. Okay, so just a second. So if I say visualize it, it is a recurrent solution of what is the max, and we need to say dp I 1 comma events I 2 plus dp next j minus 1. So I'll explain this, don't worry. So skip the what this does, it skips the event I, and this attend event I plus solve the non-conflicting events. Let's see how does it happen. Let's see how does it work. Okay. So the base case would be dp I 0 is equals to 0 and dp n of I is equals to 0. That means in this case we see like we can't attend any more events, right? We can't attend any events. So at this case there are no events. We are at the last stage, there are no events, right? And how does the algorithm works? How does the algorithm works? This is just a approach we are following. This is just an approach we had in our thoughts. But how does the algorithm works, right? The first step would be sorting the events based on what? Sort the events based on the start time. Sort the events based on start time. Okay, and then for each event we need to compute. How to compute? We need to compute the next non-conflicting event. event. How does it works? How can we do this? Using binary search. Using binary search, we need to compute the next non-conflicting event and then use DP with memoization. With memoization or bottom-up approach. And then we return k, right? What could be the time complexity for this? We are sorting the array, it could be n log n, and we are finding the non-conflicting events, it is also n log n. And what is for DP computation, how does it, like O of n, O of n into k, O of n to the power k, no, of n into k. So the time complexity would be n log n plus n to k. What could be the space complexity? The space complexity would be for the DP table, so it is just n to k, right? That's it. So let's discuss the pseudocode first. First we'll be sorting events by start time. Second step would be create an event array using binary search. Next event array, create next event array using binary search. And third, it would be initialize the DP, okay, initialize DP table, initialize DP table, DP n plus 1, k plus 1, right, with 0. K is nothing but number of events, right? If you remember, k is nothing but number of events. Okay, so next we need to write a function to find next. What is the next value? We need to write the next event. So we'll be sending the events and current index, right? We'll be sending the events and current index. The fourth point would be we use binary search to find first event that starts after event current index and ends. So fifth statement would be return the index, right? And there would be another function that would be solving that by taking as index and remaining events as parameters. As we discussed before, we have only two options: either we skip the event, either we return the event, right? So this thing does all this computation, okay? And in this, the sixth point would be if the index is equals to n, or if the remaining events is equals to 0, return 0, right? And if DP index and remaining events is equals to is already like is equals to yeah is already, we need to check whether it is computed or not. It is already computed or not. If yes, if yes, we need to return dp index and the remaining events, right? Then what will be our step? This is optional. As I said, either we have one option to skip the current one, okay, or the second option is attend the current one, right? So how do we skip it? Skip equals to solve index, right? Skip equals to solve the index plus 1 remaining events, comma remaining events, right? And how do we attend the meeting? So the next index equals to find next event, events dot index, and attend, we need to store in the attend variable the value, we need to store the value of the attended variable. So index to solve next index, comma remaining events minus 1, right? And then our next step would be dp index and remaining events equals to max skip and attend, as I've shown in our previous first approach, like when I was explaining dp, how does dp work in this regardless greedy. So this is how it works there, as I explained before. So we'll return the dp, right? dp index and remaining events, done. So this is how we visualize this approach. So let's just walk through an example based on this approach. Yes. Okay. So let's just take an array. The array is events. Okay. Events array. We have 1 2 4 comma 3 4 3 comma 2 3 1 and the k is 2. So let's just use our common sense first. So we have 2 events to attend, we can only attend 2 events. Which one would you pick? This is the value of that events, these are the values of that event. So by attending the first and second event, we would be getting the highest value, so we will be attending the first 2 events. But how would you calculate it? How would you do it? So we have visualized an approach. Let's try to walk through that solution. Okay, first our step was sorting that based on the start day. So it would be like 1 comma 2 comma 4 2 comma 3 comma 1 3 comma 4 comma 3, and then we need to solve it we'll be solving it. So solve event 0 comma 2. These are the indexes. These are the indexes, like parameters which we are sending. So we'll be solving event 1 to 4, right? 1 to 4, and either we skip it, either we attend it, right? So for the skip, we need to see 1 comma 2. This parameters are sending, solve again, and here we need to make sure that 4 plus solve, and next solve 2 comma 1, and next we need to see that non-conflicting index. Conflicting index is 2, right? And then again solve 2 comma 1. Okay, again solve 2 comma 1 for the event 3 comma 4 comma 3, right? 3 comma 4 comma 3, and then we have two options. We either skip this event or we either attend this event. So let's see. So skipping that event, we need to solve 3 comma 1, that is equals to 0, right? And attending that event would be 3 plus 3 solve 3 comma 0, and that would give us 3, right? And then last, we are back to solve 0 comma 2, and the max would be skip value comma 4 plus 3, that is equals to 7, and then we would be returning 7, right? This is how we try to solve this. We have visualized the approach, and this is how we solve the code problem. And let's try to code it in the LeetCode. So let's try to code it. So we will be initializing a global DP array. A global DP array, right? And we need to initialize a variable n, right? So this n takes the length of the events. And we need to, first step was sort the array. Which array? Events array. How we need to sort it? We'll be sorting it based on the first day, like the start day, right? Yes. This is a lambda expression. We are using a comparator, if you are aware of this. So we are initializing the DP array now. We need to take events length and the events which we need to attend. So we are traversing over the array. Right, we are traversing over the array, and how we just need to traverse until the end of the array. We need to fill the array first. So on in which which array we need to fill? The TP array with -1 and return to solve, and then to solve. What to solve? Events, comma 0, comma k. How many events that we are eligible to attend, right? And then so this is our 2D array events, and this is our integer. What integer? This is our index, where to start. This is our index to start, and this is our remaining events. So let's make it simple one. RE. So the base case would be if the index is equals to n, or what's happening? Okay. Or remaining events equals to 0, we'll be returning it with 0, right? And we need to check if it is already computed or not. If the TP index which has been sent to you, is this index has already been computed or not? Not equals to -1. Actually, first we have filled the array with -1, right? If it has computed, the value would be different. So if it's not -1, it is already computed, right? So then in that case, we will be returning the exact value which is already been stored, in it, right? And the first one is we have an option. We have two options, right? Either we skip, right? Either we skip. If we skip that option, we need to solve it again. So we'll solve it. Events, comma index +1, comma remaining events, right? And if we have another option, what is that option? We need to attend that event, like attend the current event. So if we are attending the current event, we need to check what are the next indexes, what are the next events we need to attend. So next index, right? So we need to find the next event that we need to attend. So for that we need events array and the index, right? So this computation we'll be doing next. So for this we need to create a private function, helper function, private. Actually this is current index in this. Just follow the naming conventions of Java it would be a helpful thing for you. It is a really good practice if you follow the Java naming convention every time you code. So we'll be checking the events, current index, right? Current index, end day, and left plus 1, current index plus 1, right? This is our end of the list. So as I said, we will be using binary search for the first event that starts after the current event, right? Current event ends. What are the event starts? Event starts after the current event ends. For that, we need to use binary search while left is less than right. What are we doing? int mid equals to left plus right minus left the whole by 2. This gives us a mid. Okay, if the events mid comma 0 end time is greater than the end time equals to mid, the mid position would be changed, right? Else left equals to mid plus 1, and after this loop we will be returning left, and by this we can find the next events we need to attend. Okay, so this is how the next events code look like finding the next event. And as we discussed, like we can skip the current event or attend the next event. So we have solved the current event. We need to skip the current event, and if we want to attend the next event, we need to see whether the event, what are the next events available. So we have coded for that. So we need to attend the event now, right? We need to attend the event index 2. What is 2 over here? This is the value plus again we need to solve it, right? Solve the events array, the next index, and remaining events minus 1 means right now we have attended a meeting, like attended the event, so we need to decrease it with minus 1, right? So after this DP, we need to store it in the DP index remaining events equals to math.max, which is the max value. Skip or attend, which we have skipped, or attend. We need to check. Based on it, we will return DP index and remaining events, right? So the key points that we have coded in this, like first we have sorted. Let me zoom out. So first we have sorted the array. First we have sorted the array and then made a DP table which represents max value from index I with j events remaining, and we have used binary search over here to find the non-conflicting event, and we used memoization over here, right? And the two choices are always consider both skipping and attend each event. Like we are considering the two choices like skipping or to attend the event. So alternate this is the alternative dynamic programming approach. We have also a bottom up approach, but the time complexity would vary. For the bottom up approach, the time complexity would be n log n plus n to the power k, I guess, n to the power k. So let us get into a conclusion that, like, first let's run the program. Okay, events index, event index. Current index. Okay, let's try to submit this. Great. So excellent. We have successfully solved this question using dynamic programming with memoization, and the key takeaways would be evolution from the greedy approach with dynamic programming, like DP. Yesterday, the greedy approach doesn't work when the events have different values and we have constraints over here. The state design, like thinking about remaining events as a dimension in a DP state, and using binary search as an optimization to find the while finding the next non-conflicting event efficiently. Like, and we have also defined the two choice patterns, like classic DP pattern to take it or leave it. Like, and why this approach worked, like we considered all possible combination optimally. Memoization prevents redundant calculations, like we don't have to calculate each and every time because we have already got that, we have already calculated it. And memoization is which reduces the redundancy, and binary search keeps it efficient even with the large inputs. Whether you're while it comes to the interview approach, like when there is an interview questions based on this, always start by explaining with why greedy won't work, and clearly define your DP state and recurrence relations, like which I have mentioned over in here, right? So let's see. This is the DP state and the recurrence relations. Don't forget to handle the binary search for finding the next events, and consider both top-down like memoization and bottom-up approach also. Like right now we have done the memoization thing. This could be solved using bottom-up approach also. And this problem has beautifully demonstrates the transition from greedy approach to dynamic programming. And when we see the constraints, like when we see the constraints change. There is a lot of change in the constraints, and it is a perfect example for how adding one constraints like limited events and changing the objective, right? So if this video helped you understand the problem better, please give it a thumbs up. Don't forget to subscribe to the host code for more daily LeetCode questions, and make sure you have watched yesterday video on the problem for the complete foundation. What problem would you like to see the next? Drop your suggestions in the comment boxes below. Thanks for watching. I'll see you in the next video. Happy coding.